monostable multivibrator. The word mono means single. Mono means single. Single, and what we mean by the single? That it is having a single stable state. Like this. Suppose this is a reference level, and like this state is a stable state. And if the multivibrator goes to unstable state, so this is unstable, this is unstable. If it goes to unstable, but then it comes back to stable state, it comes back to stable state. This state is stable. So it has only one stable state. Maybe this one, I chosen this stable. It may be other way around. This is stable and this one is unstable. But here, like this is a stable, and when it is triggered, if we trigger the multivibrator, then it goes to unstable and remains there for some time, but then come back to the stable state. This is the definition of multivibrator. The principle of the multivibrator, monostable multivibrator, depends upon the charging and discharging of this capacitor. How? Like this is a supply, there is a resistor, here is a capacitor, and here is a switch. If the switch is closed, then what happens? Current will take a path along this side to flow. Current of the battery will take the path along this side to flow to ground. And there is no role of capacitor if this switch is closed. Now secondly, if this switch is open, like this circuit, this is open, now current cannot flow along this path. So what happens? This battery will charge the capacitor now. The capacitor will start charging with this voltage. The if switch is open. Now in monostable multivibrator, the action of the switch, that it is closed or open, it is by transistor. It is by transistor. If the transistor current is flowing, then it is closed switch. If the transistor is open and no current flowing, then it acts as a open switch. Okay, this is the principle of monostable multivibrator. To explain the working of 555 IC as monostable multivibrator. Now here, the pin number 8, it is at VCC supply. Now the threshold pin, okay, threshold pin, it is connected with the capacitor. The control voltage, here the voltage is because the resistor R is connected, the voltage becomes here 2/3 of VCC. If VCC is 5 volt, and here becomes voltage, here becomes voltage like a 3.3 volt. 3.3 volt. Remember, this is negative terminal. Positive terminal is connected to the capacitor. Now coming to the lower comparator. Okay, this is our first comparator. Now this one is the second one. Positive terminal of the second one is connected with fixed voltage. That voltage is 1/3 VCC. If VCC is 5, then it is 1.66. Here voltage is fixed to 1.66. And the negative input of the comparator, it is pin number 2. It is called the triggering. Now triggering pulse is given when you close the switch. If the switch is open, then what happens if the switch is open? This is a 5 volt supply, then the 5 volt comes here with negative, 5 volt comes here. Here is 1.66. So 5 is greater than 1.66. So this is at low voltage. And S is low mean if the S is low, Q complement will be high. Q complement will be high if S is low. Okay. If S is low, Q will be low, but Q complement will be high. Okay, now I am coming the stable state. I am going to explain the stable state. Okay. For the stable state, this switch is open. Switch is open, 5 volt, 1.33 mean low. S low mean Q complement high. Q complement high mean this NP and P is high. Transistor on. If transistor on, then from this supply the current will start flowing like this. So current is flowing like this. So current will flow like this. Okay. Now as this is high, this is not gate, this will be low. So output is a low. This is a stable state. Okay. This is what is a stable state. Current is flowing, and if there is no charge on the capacitor because the current flowing through this path. So okay, this is the stable state of 555 time. Now I am coming the second state, unstable state. Unstable state. Now for unstable state, what I am going to do? For unstable state, what to do? Now I am going to close the switch. Switch is closed, Now here the current flows along this path. Current flows along this path. Here the voltage becomes 0. As is a grounded terminal. This is grounded. Here the voltage becomes 0. What is the voltage here? 1.66. So this is 0, this is 1.66. The plus is at greater volt. So this becomes on. On means high voltage. This is high. Set is high. Set is high means Q is high. Q high means Q complement low. This becomes low. Transistor becomes off. And if this is low, output will be high. So this was a stable state. Now what is going to happen? What is going to happen from stable state to this is a stable state. Stable state to the output is going high. The output going high. High means this is unstable. Now state. This is a stable. So output is going high. As output is going high and this is low, transistor is off. Now no current can flow along this path. No current can flow along this path. No current can flow. This capacitor starts charging with this voltage. The voltage over here starts increasing. Voltage over here starts increasing. Then the voltage increases like this, because the voltage on the capacitor, it increases like this. When it reaches near 2/3 VCC, it reaches at this voltage 3.33, what happens, and just crosses 3.3 volt, what happens, this becomes high. Now this becomes high means reset is high. Reset high means Q becomes low and Q complement becomes high. When this is high, transistor becomes on now again. If transistor is on, this is high, this here this becomes low, because Q complement is high, here becomes low, and because Q complement is high, transistor is on. Now again the current starts flowing. Again the current starts flowing, and the capacitor discharge. Capacitor discharge. Now capacitor voltage comes down, but again, here the output is low, because it was high. This output is low. The output goes to low again. So this is again a stable state. So this was stable, but when you close the switch, it goes to unstable state, mean high, remains high for some time. So long as the capacitor is charging, it remains high. When the capacitor charges to 2.2/3 VCC, this potential becomes higher, this becomes on, reset on. Reset on mean, when the reset on mean Q is low, but Q complement high, output is low, Q complement high mean transistor on, and whatever the charge was on the capacitor, it starts discharging through this path. So it's completely discharged. Again this becomes off. This transistor, this becomes off. Okay, and here the output is low. The stable state is again reached. But it was a pressing key. Once you press, and then it automatically unpress the switch. Okay, once you give the triggering, what happens is it trigger, it goes to unstable state. Then you left the key. Then unstable state will be there so long as the capacitor is charging. Okay, then there is no role of this switch. So you just press the switch and release it. Capacitor starts charging and reaches to this value, then automatically the output comes down and attains again the stable value. So this is the working of monostable multi-vibrator. Thank you. We to learn about the pulses, triggering pulse and output and charging of the capacitor. So look, when this is here, when we close this switch, here becomes, what becomes here, the 0 volt. Here becomes 0 volt. 0 volt. This is at high. Here this is high. So this is the lower comparator. It gives the high. If it is the high, the set is high. Set high means Q complement. This is low. this is low, output will be high because this is a NOT gate. If this is low, then the capacitor is, not capacitor, transistor. This transistor is off because this is low and this is NPN transistor. Current cannot flow, and during the triggering pulse the capacitor will start charging. So if this is our triggering pulse, it is VCC, it is 5 volt, but when you close the switch it becomes 0 volt. So just when it becomes 0 volt, this is low, this is high, it is high, this becomes low, this becomes low, mean output becomes high. So output goes from this low value to a high value, and it remains at high value, during that, because this transistor is off, the capacitor charging up. As capacitor charge, and the capacitor voltage increases and reaches to 2/3 VCC and just crossed. This remain high, just crossed. What happened? The upper op gives a high here because this voltage is higher now than 2/3 VCC. This reset is high. Reset high mean this is high. This is high mean this is high. Transistor on and current starts. This current starts flowing and capacitor discharge now. Capacitor discharge. So this is the discharging of the capacitor. Capacitor totally discharged, and that this was high, this becomes low. So output becomes low now. So it depends upon, this duration depends upon like how much the capacitor takes time to charge and to reach the 2/3 VCC value.